How many colors can you name here? The Piraha people, a tribe from the Amazon rainforest, would say 0. And it's not about color blindness. They don't have abstract words for colors. Instead, they use familiar examples, sky-like or blood-like. Another answer is 1, from the Bassa language of West Africa. Bassa speakers use Ziza for all warm colors, white, yellow, orange, and red, and Hui for all cool colors, black, violet, blue, and green. In that system, everything you see here is Hui. This may seem weird, but think of a geologist who knows dozens of rock names: Leurzolite, Phoidolite, Grison, while most of us would say rock to all of them. Isn't this a bit like color-scarce languages? English has 2 core color terms here, blue and purple. Remember, we're talking main colors. Cyan or sky exist, but they aren't basic categories. There is a language with even more dominant terms, and we're going to find out how that shapes perception and attention. We'll also see how this idea can improve life skills, like emotional management, logical thinking, and even math. 1. The Sapir-Whorf hypothesis. Language relativity, aka the Sapir-Whorf hypothesis, is the idea that language influences cognition, how we think, interpret, imagine, and perceive. The strong version claims that linguistic categories limit cognitive categories, meaning you couldn't separate 2 rocks into different groups unless you already had words for those groups. That extreme isn't true, since new words, based on existing concepts, do get invented. But knowing the words still makes you faster at spotting differences, and we'll demonstrate this. 2. In math, Piraha also lacks exact number words. They can pair equal sets, matching stones to sticks, but if those sets are hidden, they struggle to remember how many items there were. Without a word like tree, it's harder to hold the exact concept in mind. This shows that having a linguistic label for a concept like a number helps us retain and process it, unlocking new abilities. Another study found that after just learning new color words, participants were faster than a control group at identifying those colors. The same thing applies in math. Sometimes a problem is solved by identifying a pattern. 2, 4, 6, 8, 2, 4, 8, 16. We easily see that the first adds 2 and the second multiplies by 2. But in more complex cases, knowing the terms arithmetic progression when the sum happens and geometric progression when the multiplication happens helps us spot the rule faster. 3. In logic. Taking this further, we can improve our ability to spot errors in argument by learning the names of logical fallacies. Take this example. A movie is either a masterpiece or trash. What's wrong here? It presents 2 extremes as the only options, when more exist. A movie could be just fine. This is called a false dilemma, or false dichotomy. Now try this. The project will either be a total success or a complete failure. Having learned false dilemmas, it's easier to catch the same mistake next time. 4. In attention and identification. Now imagine 2 Russian children drawing. One says, "Please give me the Sini and Goluboy crayons." The other responds, "Here." The English-speaking person is confused. It's all just blue. But in Russian there are 2 completely separate everyday color categories, Sini for dark blue and Goluboy for light blue. These children grow up constantly separating what we lump together, and studies show that they can tell the difference between shades of blue faster than we can. Russian speakers are quicker at distinguishing and classifying light and dark shades of blue compared to English speakers, due to the presence of distinct basic color terms. Their words reshape their perception, as if they've unlocked the superpower of visual filter, sharpened by language. This isn't limited to vision, it happens inside us too. 5. In emotions. Our ability to solve problems relies heavily on identifying the problem. For example, in the context of medicine, we go to a doctor in order for them to diagnose the problem, and only after this can we start working towards solving it. The same rule applies to emotions. Having a wider vocabulary that describes emotions can enhance our ability to distinguish between them, as shown in the study about the words for light and dark blue in Russian, and therefore makes it easier to manage them. Think of two people feeling a pit in their stomach and an urge to withdraw. One says, "I feel bad." The other says, "I feel shame." The second person has emotional granularity, a vocabulary that allows them to zoom in on their internal state. Instead of being lost in the fog, they can pinpoint exactly where they are emotionally. And that makes all the difference when trying to respond. Knowing whether you're disappointed, frustrated, anxious, or lonely isn't just for poets, it's a mental tool. People with higher emotional granularity handle stress better and resolve conflicts more effectively. Again, language turns on a light when we feel the dark. 6. Put into practice. So what can you do? Identification is the key to finding solutions, and language helps us identify. There are many areas where expanding your vocabulary will boost problem solving. Math, logic, and emotional management are just a start. While learning a new skill, focus on its core vocabulary, especially if it's a mental skill.